Farscape Engineers Inspector Summary Video. Here we are in Harvard Square. The buildings here basically are pre-existing non-conforming fire escapes. What we have here that needs to be addressed on this one is very similar to the other fire escape that we're about to look at, but again, new grading, so not really a lot of problems with the grading. Through-bolted, verified. We can verify the through-bolts. The welded connections that we have here is one of our main concerns. So if we're going to verify that welded connection, which is very difficult, by far one of the most difficult things is the welded connection. So a lot of times we rather put a bolt on that and avoid the welded connection issue, so we don't even have a disclaimer on welds. We don't want to disclaim welds ever. So again, it's just the post, just the corner post. A lot of times a piece of flat underneath that, basically marrying that corner and negating the need for that weld to be verified. Silicone shut anything into the building, so that there's no water getting in there and getting weeping water into those lag screws. This ladder has a couple of issues. Again, we can visually verify this, but again, because it's welded in and around here and it's smaller, it's about 12 inches here, but it is a pre-existing non-conforming, so we'll speak with the city official whether they'll allow. But my main concern is that we can give an opinion on this, but a lot of times these are punched through and welded on the other side, and that's not the case here. These are all welded, and these tend to have the welds basically eat from the inside out, so that's the only concern that we have. Another thing too is the lag screws they're all original hardware squares. Okay, so again, we can torque onto those, and if they look good, we can render an opinion, again with a disclaimer letter all the way to the top. So the angles tighten back. We need to seal those from above so the water's not getting in there and rotting those. The through bolt we need to verify on the inside that they're in good order, and usually that's a small hole in the wall. You've got the angle with a bolt on the end there, so that's to verify and negate the need for that welded connection. So some of this work has been done from the past. So both floors have the same issue. So your main real issue is going to be this ladder to the building, which is a pre-existing building, to make sure that no more water is getting on top of that. And as you can see, what kind of happens when water gets in there and it starts to crush. See, this is all crushed. See how that's crushed? And now that makes these areas suspect. And so these are the things we have to concern ourselves with. They also have this weld here, see? And a lot of times to negate this, we put an angle or a flat going across, bolt here, we negate the weld. So that's what I would recommend on this fire escape. Is again, this fire escape with 25% repair will achieve a certification in lieu of a load test, because some of the things that are here are very minor in nature. And that would include changing out all those bolts, put in new lag screws on all levels here. My only concern is whether or not we can put in a quick little angle clip here, basically reinforcing. So imagine a very small angle clip here, 3/4 wide, just enough to put a through bolt, a small bolt here, and basically what you're going to have is the ability for it to basically reinforce all these bars going down. So whether or not to build a new ladder that's 18 inches wide is easier, or whether to keep this one, that's the case. But this fire escape here has very little that's going to take to achieve certification in lieu of a load test. Otherwise, the fire escape needs very little to issue an opinion letter on the remaining pieces of this fire escape, which was refurbed probably in the past 5 years. Some activity was done to it. But again, the welds were never neutralized or negated in that repair. Any questions, Fire Escape Engineers? 866-649-0333. Fire Escape Engineers Inspector Summary Video. We have this fire escape here, similar to the other fire escape on that yellow building there, here in Harvard Square. What the concern is that some work was done to this fire escape. So it does have new rails, looks like new grading, or new style grading. A lot of the through bolts are visible, so for sure you got a through bolt into the building. But what we have here is there's definitely something happening because of the age of this building. You definitely see some bulging and crushing going on here, and on the other side also. And then when you go up to the very top, you have the same thing happening. There's a crush going on. And again, I think the wood is soft, So what needs to be done, it's going to be a combination of a contractor, identifying just what's occurring in that area there and what's occurring in this area down here. So she's pulling out this way, but she's crushing that way on both levels. We may be able to transfer some of that issue as a possibility to buy some time, if it allows. I don't think the alignment is no good with this going down, but to basically transfer the upper platform down, as far as transferring with some supports coming down to here, and then having these supports come down here, and maybe creating some sort of framework where it ties back into the building, and then those legs come down. But I think we might have a better chance of spreading the load with an angle there along the wall temporarily until the wall gets dealt with, and upstairs the same thing, run an angle along the whole length of the 3 supports, so that way it's crushing or compressing against the entire wall there while this matter is resolved in the future activity in this building, which I believe is due for some activity. So the railings are new, but they're welded, so we never give an opinion on a weld. What we want to do is basically pop a bolt so that we have a mechanical connection on any weld. So these corners, both corners, need to be dealt with. As far as the grading and the frame, again, a simple bolt will negate that and get it towards certification. And then the last piece, which is similar to that building over there, is this ladder. It's a pre-existing non-conforming ladder, only about 12 inches wide, all welded. It's not through. Usually these are punched through so that they weld it here, but this one is welded here. So to keep this existing ladder, we need to put a little clip here with a bolt, no welding, a little clip here with a bolt, and that way we're just basically reinforcing all these bars going across. We have to make it so that hopefully it doesn't affect your hand. And our concern is just what's happening in this going back into the building. So we need to verify each one of these. If you want to just get an opinion, verify each one, but they've been sealed, as you can see, and that's stopped to the water. Or since there's so little left on this fire escape, if you just change these out, there's not going to be that you're at certification level. So taking these out, and a lot of times, because if it's a 3/8 in there, you got to put in a 1/16 higher or an 1/8 higher lag screw on all of them. And as you can see, we've got definitely some wall damage here. So that's the main concern on this, is we can sort of temporarily shore this thing up and still achieve certification on the existing building as is, because we're going to basically spread the load here and up there, and then deal with the ladder. And then whenever this building gets done, it'll be the fire escape will be required to recertify once all the work is done. But we definitely see some bulging and things happening on this wall, that it's basically got waves throughout. We just got to make sure that we're not crushing in any way the situation. Any questions? Fire escape engineers inspect the summary video. 866-649-0333. 866-649-0333. Fire escape engineers inspect the summary video. We're doing the 7 Appian in Harvard. These 2 fire escapes are very similar to each other. So what I say about this one is going to be said about the other one on this fire escape. So there's a blue one and there's a yellow one that is has some issues. So we're going to talk about the fire escapes and discuss just what's happening on this. So the big issue on these fire escapes is gonna tend to be the ladder is going to be one of the issues that we're concerned about. See if I can get my pen to work. So the ladder is one of my concerns. There is a through bolt that's happening everywhere, and there's also some crushing that's happening on the bottom of some of these pieces here. So let's just go one photograph at a time. Again, we're going to try to achieve certification by changing a bolt out, or we're going to try to achieve an opinions affidavit if we determine that the existing 50 to 75-year-old bolt is good. So on all the ladder, 50 to 75 years old, these bolts, these square head bolts, again, original, We need to silicone shut the tops of these so the water starts getting in the top. And once we've done that, this fire escape will have an opinion on it. As far as whether or not we can certify it, we need to take these bolts out and upsize. So if this bolt is 3/8, I need to go to a 1/2 inch lag screw because the wood that the 3/8 is in now is a little bit soft, so it's got to be up. That will achieve certification. Otherwise, give it a little twist. If it's nice and tight, then you can just render an opinion on that bolt. The ladder is going to have some welded bars on there that we're going to talk about in some future photos. Now, what we're getting here on some of these fire escapes, we're getting a little bit of crushing that's happening down below. And this crushing, I don't know if they're going to do the siding again or whatever the issue is there. So we may be able to temporarily put a piece of angle going across, let's say 12-inch long, put this angle with a bolt there and put in a couple of lag screws there, simply because this is crushing on some of the fire escape. This is the blue one and the yellow one. So as it basically pulls on the through bolts on the back, it compresses down, but it looks like there's some soft wood going on there. Any place that has the soft wood, we can put in a 12-inch piece of angle there temporarily until the siding of the house is dealt with, or you can even do a piece of angle all the way across and then tie it back in, and that will be a temporary measure until the work is done. What we have here also on these through bolts is that the angle is welded to a piece of flat, and again, anytime we have a welded connection, we try to basically back it up. So a belt backed up with suspenders eliminates the need for us to verify a weld. So this is all welded in the back end here, and what we need to do is put in a clip, an angle clip that basically comes here and goes there, so we can bolt to the top and then lag screw it back into the building so that we can marry this joint. Okay, the grating is fairly new style grating, so we're not worried about that. Here's another welded connection that we need to just basically negate. So as soon as we put an angle here, we can put a bolt through the 1-inch solid, and we can put a 3/8 bolt through there. Keep the weld, but now you just need to silicone shut it so that that weld never gets any more water intrusion. Same thing on the other side. Put an angle here and an angle there. So it's a 2x2 angle, for example. We put a bolt here, we put a bolt here through. So every time you have a welded connection, you can negate the welded connection on a major structural connection, usually the posts on the corner, to avoid having to give it an opinion. So we never give an opinion or ever load test a weld. We can only rebolt it so that we can basically negate it. Okay, so here's another point where there's a welded clip, and this angle is welded to this flat. So if we can create a clip that will basically negate this weld, that'd be great. That weld, again, here's the crushing point that we're having. Here's the welded connection corner. The grating is in good order. The railings are fairly new, probably 5 to 10 years old. And any tiebacks into the building. Again, if that's an original bolt, as soon as we switch it over to a new lag screw, then it's certified. If we just touch that original bolt and turn it to make sure it's tight, then it's an opinion. So you have opinion on one side if you leave original behind, and you have certification that occurs when you switch the bolt out. And this fire escape, 75+% of this fire escape has already got new hardware on it. I would just reinforce the welds, change a few hardwares out. It's so small, and achieve certification on this. But we do have another issue, and that is the wall is pushed. So there is definitely some compression happening on this wall. We don't know what's going on, and the wall looks pretty poor, so I don't know if this building is getting redone. On the angles at the very top where this railing makes a corner, we normally recommend underneath a piece of flat that runs underneath, so that you put a bolt here and a bolt there, and it basically negates this corner. And that reaches certification. Otherwise, I can give you an opinion, but again, anything that's a welded joint, we try not to give you an opinion on, too much liability. So as you can see, some bulges on the wall where the screws go into the building. We have our corners to deal with. And again, both fire escapes, they're exactly alike. They're both two-story. The blue one and the yellow one. But you know, definitely there's some wall damage that's occurring here. I don't know if some of the shingles are rotted. They have silicone shut here, but again, water has weeped into the past, so we need to render an opinion or change out these bolts. Okay. This is the yellow one. As you can see, it's the same situation. There's some crushing going on below. The ladders go to the top, so let's continue here. As you can see, the same issue with the weld. See that crack? That crack there and that crack there. That's an indication that water is getting in there somehow. Okay, let me see if I can. There's already a 3/8 bolts in that corner there, because underneath there's an inside clip on the inside, so the bolt's already there. So a lot of times you can put the angle clip on one side, or put the angle clip on the other side, or even put a piece of flat that goes this way. As soon as you put a bolt here and a bolt there, you've basically eliminated that welded connection that we're having a concern about. You see the crushing happening there, and again, we're doing with both these fire escapes because they're both the same. This railing, this ladder, the issue that I'm having with a ladder is that usually the rod, the 5/8 rod that goes through these, is welded on the opposite side. That way, in case there's a weld failure, the rod's not going to drop in any way. But on this one, it's welded all around here, so we're going to have to put these little angle clips with a bolt on this side supporting these in order for this ladder to stay. The welded angle brace here is just welded here. So as soon as we put in a piece of flat that goes all the way across, we can put a bolt back here and a bolt over here, and that eliminates the need for us to verify that weld. So again, same thing here. You can put an angle and basically put a bolt and reinforce that welded angle on the ladder going all the way to the top. So all these welded connections need to be reinforced. Original hardware needs to be verified, or it needs to be replaced to get a certification. As you can see here, there's deterioration on the wall. So whether or not water's been getting in here, we don't know, but it doesn't look good. Quite a bit of deterioration. These are going to need an angle here and an angle there, so that way I can put a bolt going through, and then the angle, the little bit of, probably 3/4, 1 inch angle, is going to help support this welded rod. It's all welded on this side, but I need either to x-ray or weld every single one of these bars. So, every single one of these bars needs to, in order for it to go another 5 years on a weld, I need an angle that's going to go, it's going to go like this, like this. So the angle could be 3/4 to 1 inch. There's going to be a bolt here, but then because it does this, basically all it does is support this bar from ever dropping, because I can't guarantee that weld. If that weld was punched through and welded on the other side, I'd have no problem with this, because that's the normal way. So this is supposed to go through the angle and be welded on the other side. Instead, it's butt jointed and butt welded right up against the flat. So if there's any corrosion inside this weld, this bar can let go, and there's nothing backing it up, and that's why you punch it through the flat. Again, it's only 12 inches wide, so it's pre-existing non-conforming. Rail, usually they're about 3/8. We do have lead. Anytime you have a welded connection like we have here, as soon as you put in a plate, put in a bolt, drill a bolt through there, basically. We negate this weld that's in here. We've got some connections. Any connections that have rust inside, we need to get in there, clean it out, and then we need to silicone shut it. And anything up against the building, we need to silicone shut it. But it looks like there's going to be some work up against the building. Here's the whole welded connection up against between a piece of angle and a piece of flat. And a lot of times by putting in a piece of angle here, we can bolt it there, and we can bolt it there, and there's the joining of the two, so that we don't have any issues with the weld ever breaking. We got to seal it from above to make sure there's no water getting in behind this and eating this weld, because these welds will rust from the inside out. That's why we don't want to guarantee welds. We don't want to x-ray welds. We just want to reinforce them. So here's a lot of it of the crushing that's happening. Here's some more crushing that's happening on this fire escapes on both buildings. It looks like the wood is very soft. It's a very old building. So, and here's another great amount of crushing. So again, we can spread the load with a piece of angle temporarily until they fix what's ever going on here, or we can run a piece of angle across the whole length and marry the 2 feet down below, and then when they're working on the building, they can assess the situation behind there, why it's crushing, which is not a norm. Again, any of these angles that basically come this way, that has a welded joint, which is right there, put a bolt here, put a bolt there, we've negated the weld, seal everything from the top down. And again, if that you want to verify that bolt and give an opinion, then you can relieve original by giving it a twist to make sure it's nice and tight, or you can just take that out and upsize a 3/8 to a 1/2 inch and lac screw about 3 inches long. And what's going to happen is now you certified that ladder. Every one of these rungs is going to take a little support clip on either side of each rung every 12 inches. So every 12 inches I want to see a little angle clip every 12 inches. And that basically will allow you to keep this original ladder. And then any welds here needs to be, with a new plate, with a bolt and a bolt. So sometimes it's just cheaper to replace the ladder and come in with a code compliant 18-inch ladder as opposed to this 12-inch ladder. And that's both these buildings have the same exact structure: a small fire escape at the top, a slightly larger fire escape at the bottom. This is a new rail. This is a new rail. All welded connections, so it's really about reinforcing all the welded connections. And then again, yes, the ladder is only 12 inches, so that's not code compliant, but it is pre-existing non-conforming. But then all the bars going across the ladder, are welded on one side only and not punched through and welded as normal. So, in quick review, opinions is basically confirming what you got there is good. Otherwise, if you reinforce it or rebolt it, you get certification. Crushing going on this, so we need to either temporarily secure this with an angle so that the crushing doesn't occur. Just spread the load out a little bit more with an angle in the bolt, and then when they fix it, leave it back to the original. Otherwise, you can just marry these two. You can run a long angle marrying the two, but it's not that huge. So all the through bolts are a piece of flat welded, so we need to marry the clip. Any silicone, any rust in any connection, clean it out and silicone shut it. All the connections into the building are just that. Some of them are sealed, some of them are not, but it's all original hardware. The railing is improperly welded on just one side. It should be welded, punched through and welded on the opposite side. It's not, so clips are required on the entire length of the ladders and all the 12-inch. Just seal it all up, identify what's going on with this building as far as whether they're going to keep the original wood, whether there's anything going on, but definitely water has penetrated some of the lac screws. A lot of crushing on both buildings. Original hardware, don't forget, all the welded bars here on the rail are minor structural. They don't need to be backed up with anything, but the major corners, you need to back it up with the bolting. So underneath, run a piece of flat underneath, bolt there, and we're good to go. Put the carriage bolt head on top so we don't get anything happening. Don't forget the frames. The objective is try to get these welds to be negated through a bolt. That'll happen there. So again, anything that's a welded connection, just do your best to basically put a backup on it. We call it putting suspenders on a belt. So as you can see here, two exact fire escapes on two separate buildings next to each other, and the problems are the exact same. It looks like we have a wall that needs to be identified during repair to see what's going on behind it, so that this fire escape can properly pull and compress upon it. There's some temporary measures that can happen and still achieve certification on these fire escapes. So that way, even if this gets fixed 5 years from now, some of the work that we're talking about here will certify the fire escape in its current condition. So one of the things we can do is run a length of angle over there, run another length of angle over here if you don't like what's happening on the wall, and the same thing here on this building. Run a length of angle here and run a length of angle there. But otherwise, everything described on this will be it's a pretty easy repair on this fire escape to achieve an opinion certification, or if you do everything that we talked about on this, it'll achieve full certification without a disclaimer letter and in lieu of a load test. Any questions? Fire escape engineers, inspect the summary video, This is 7 Appian for Harvard. 866-649-0333. 866-649-0333. This is Cisco Meneses performing the evaluation.